Beer-Lambert's law.
We talked about spectroscopy before, but spectroscopy is the study of electromagnetic radiation emitted or absorbed by given chemical species. Since the quantity of radiation absorbed or emitted can be related to the quantity of absorbing or emitting species present, this can be used for quantitative analysis. We're going to do our next lab over this stuff. So, although there are many spectroscopic techniques, we will focus solely on the procedure based on the absorption of light, visible light. If a liquid is colorful, it is because some of the components of the liquid absorb visible light. And so then not all of them, some of them are transmitted out, and that's what gives us the color. In a solution, we know that the greater the concentration of the light absorbing substance, the more light is absorbed, so the more intense the color. So if you have a concentrated solution, the color is more intense than the less colored solution, or the more diluted of the two. So like, think about this as your Kool-Aid that you may or may not drink. Okay? So what we will do with this in our lab is we will use what's called a spectrophotometer to show and measure the quantity of light that is absorbed by a solution. The schematics are shown here, and this is in your notes, so you can look at this as we talk more about it. You have a source of light that will emit all wavelengths of light, so it's going to send white light through your sample, and it will go to a detector. And so that will the detector will compare the intensity of the incident light, which is the amount of light going in, versus the transmitted light, how much light passes through it. And with those two values, then we get what's called transmittance. And it's the ratio of the incident light to the transmitted light. Sorry. And the amount of that can be, if you take the negative log base 10 of it, that gives us the absorbance of that light. We can also express this in what's called the Beer-Lambert law, or sometimes it's known as Beer's law, where the absorbance is A, is equal to, that is the Greek letter epsilon, and that stands for the molar absorptivity, or molar extinction coefficient, in units of liters per mole centimeters. L is the distance the light travels, or length, in centimeters, and C is the concentration of the absorbing species. So if we can read out what the absorbance is, and we know the length that it's traveling through, which would be like our test tube. It's also known as a cuvette that you put into the the spectrophotometer. And then we knew the molar absorptivity, the constant, then we would be able to directly correlate the absorption to the concentration. And we can graph it. So if we know the length and we know the molar absorptivity, measuring the absorbance will allow us to calculate the concentration of the absorbing species. So that's what we're going to do here. We've obtained a being solution containing an unknown concentration of cobalt ions. The absorbance is measured at a wavelength where the molar absorptivity is known to be 12 liters per mole centimeters and found to be 0.60. The width of the sample tube is 1.0 centimeters. What is the concentration of the ions in the sample? So, if we're looking at this equation, by the way, the length is usually always going to be 1 centimeter. It's the size of the cuvette or the test tube that fits in the instrument. So your L is the 1.0 centimeters. The molar absorptivity is the E, and that is our 12 liters per mole centimeter. And we know that the absorbance is 0.6. So that is the A. Yes. So we are going to solve for concentration, which is C. Okay. I don't know. Do I have an extra slide? No, I don't. Okay. So going back here, let me just erase all this stuff. Okay, so we know that we have 0.60 is equal to 12 times 1 times C. So when you solve for C, what do you get? 0.05? Yes. Okay. You should take 0.6 divided by 12.
Yep.
Okay. Now let's report it in two significant figures. So you could just add a 0 at the end like that if you wanted to, or you could say 5.0 times 10 to the negative second. And what do you think the unit is going to be? Yep, you could say moles per liter, or you could say molar. Either one would be correct. Okay. So this is just to show how the equation relates to each other. All right. With that. So I'll give you a second to write that down. If we rearrange the equation where we have concentration and absorbance on the same side, then this will help us to see that the product, when you plot A versus C, the absorbance versus the concentration, it is a linear straight line. So the slope version would be the molar absorptivity times the length or the width of your cuvette. And so we are going to be doing these type of calculations with the graphing in our next lab. The homework problems on AP Classroom for this, the 12, 13, or the 12 and 13 section, there's one question that's about 12, and then there's 3 about this stuff. And they do have some graphs for you to help relate that. But you just need to know that when you take the absorbance versus the concentration, for now, that will give a straight line. Okay? And so they're directly proportional because they give a straight line like that. Okay? So after the test, we'll do the lab.